Good evening, everyone. This is the summary session for the problem solving sessions of the course Geotechnical Engineering 1, and already the 12 live discussion sessions, 12 problem solving sessions, they have ended yesterday from my end, and the sessions were very interactive, and many topics, important topics of this course, Geotechnical Engineering, have been discussed. Many numericals have been solved with insights into the conceptual understandings of the main important chapters of this course. So now, in this session, in the form of questions and answers, it is going to be a summary, an overall discussion type of all the chapters, the major chapters that has been covered. So here I have incorporated some questions taken from each individual problem solving sessions, and I have tried to incorporate them so that using these questions and answering these questions, we can have a solid discussion on the overall concepts of the chapter studied in this course, Geotechnical Engineering. So without a further ado, I will just straight away go to the PPT. Yes. Okay, so good evening again. This is the summary session for Geotechnical Engineering 1. So as of now, what we have seen in this course, these were the syllabus. This is the syllabus that has been followed for the problem solving sessions, and these are the chapters that has been discussed in the problem solving sessions. So in the beginning, it was the origin of rocks, origin of soils and rocks and rock cycle in the first week. Then it was the basic relationships, index properties of aggregates and soil. Then in the third week, soil structure and the classification of soils was discussed. In the fourth week, concepts and numericals on soil compactions were discussed. In the fifth week, soil water statics, that is the effective pressure. Someone has joined. Yes. Yes, so I have just started the discussion part, going through all the topics what has been covered in brief, and then I'll start with the questions and answers. Okay. So the PPT is visible, right?
Yes, sir. Yes, sir.
Okay. Okay. Fine.
Good.
Yeah. So in the fifth week, it was soil water statics, giving insights into the effective stress, effective pressures in soil, the effect of total stress, effective stress, pore water pressure. In week 6, flow through soils, quicksand condition. There is a seepage analysis in the soils was discussed. In the 7th week, permeability and methods for its determination. Okay, constant head test, falling head test. What do you mean by permeability of soils? Formulas, numericals, everything. In the 8th week, flow nets and stresses in soil from surface load. So this chapter, stress from surface loads, has been divided into 3 parts, and it was discussed in 3 consecutive weeks, 8, 9 and 10. In the first part, I think Westergaard's theory, everything, the general concept was discussed. In the second, that is in the 9th week, I believe Bozin's theory was discussed, and in the last week, that is the week 10, Newmark's chart and contact pressures on soil was discussed. In the 11th week, the chapter was consolidation of soils, giving a brief introduction and some basic conceptual sums on consolidation, which was followed by the settlement of compressible soil layers. This is the last class in week 12 which was held yesterday. So having said that, I am going to start today's discussion, the summary session, where I am going to just solve some questions based on each individual chapter taken from this each individual live discussion sessions, so that the ideas you can just revisit and strengthen them accordingly. Okay, so let me start with the first question of today's discussion. Yes, which of the following type of soil remain at their place of formation? What is the answer?
C.
Yes, residual soil is a type of soil that remain as their place of formation. Why? Because aeolian soil, they are transported by which agent?
Wind, sir.
Yes, wind. What about marine soil? Sea water, right?
Water.
Yes.
Yeah.
What about this one, colluvial soil?
Gravity.
Gravity. Okay, so residual soil is a type of soil among this that remain at their place of formation. All right. Let's see the next question. What is degree of saturation? Options are moisture content of soil mass in its natural state, ratio of volume of water in the soil mass to the volume of soil solids, ratio of volume water in the soil mass to the total volume of voids in it, or moisture content of soil mass in its saturated state. So what do you mean by degree of saturation? What is the definition?
C1, sir.
The third one, right? Third option.
Yes, sir.
Yes. Ratio of the volume of water in a soil mass to the total volume of voids in it. That means when we say degree of saturation, okay, someone else has joined. Dheeraj Raghuvanshi. Okay, Dheeraj, I don't know whether you know it or not, but this is a summary session. Okay, you can tell me the answers because it is just a revision of all the sessions. So the question was, what is degree of saturation? Someone has answered it very correctly. Ratio of volume of water in a soil mass to the total volume of voids in it, because the formula is volume of water in a soil mass to the volume of voids, and that we express as percentage, isn't it? We express as percentage. So this is the degree of saturation, volume of water in a soil mass to the total volume of voids in it. And what do you mean by moisture content? Can you tell me what is the definition of moisture content? Basic definition. Yes, tell me. You know, right? Yes, hello. I can't hear you. Your voice is not so audible.
Mass of the water.
Yes.
Can you hear me, sir?
Yes. Now I can hear you.
By
Mm-hmm.
mass of the solids.
Mass of the soil solids. Yes, very good. This is moisture content. Okay, so in this, index properties of soil, that's an important chapter. We need to remember one thing very specifically, that which definition concern the volume and which definitions concern the mass. Okay, how are the index properties correlated with each other? What is the relationship between one index property with the other? Now remembering those formulas, these things are very important. Okay, so like this, saturation with respect to the volume, moisture content with mass, these things we should remember very carefully. Okay, so back to the question now. Degree of saturation means ratio of the volume of water in a soil mass to the total volume of voids in it. Correctly said. Okay. Next question. Yes, the maximum water content at which a reduction in water content will not cause a decrease in the volume of soil mass. What is the answer? I believe you have given answer A or B. Let Dheeraj speak now. Let him give some answer. Dheeraj, if you are there, you can tell me the answer of this question. The maximum water content at which a reduction in water content will not cause a decrease in the volume of soil mass. What is the answer? Dheeraj? I believe you.
I guess shrinkage rate.
Yes, you said shrinkage limit, right? Yes, shrinkage limit is the correct answer. Good. Shrinkage limit is the correct answer. Why? Because we need to see this graph. We need to see this graph. Okay, we need to see this graph, and we need to understand that which parameters lie at which positions. Okay, just a moment. Just a moment. Yeah, sorry. So, yes, which one is the shrinkage limit? Can you tell me? There are three, boundaries: WL, WP, and WS. Which is the liquid limit? Sorry, shrinkage limit. Anyone can tell this?
I think WS.
Yes, WS, because when we are coming from the right hand side, we are saying that a soil has water in it, and now gradually we are drying the soil from A to B and then to C. Okay, so a point comes when we cross this one. This is the liquid limit. Okay, now the soil, if it has more water than this liquid limit, it will be in the liquid state. Now as we start drying the soil, it will come from the liquid state to a plastic state. Plastic state means it is not in liquid state, but it is highly deformable. It is highly deformable. Okay, this range that between WL and WP, WP is the plastic limit. This range between WL and WP, it is the plasticity index. Okay, plasticity index, WL minus WP is the plasticity index. Within this, the soil behaves plastic, that is highly deformable. Now drying beyond this WP, drying below this plastic limit, we get the soil in semi solid state, which is stiff in nature, Now up till B, as we dry the soil, there will be a decrease in the volume of the soil, as you can see, decrease in the volume of the soil. Now at B, that when we reach the shrinkage limit, we start again drying the soil, then we will see that though the moisture content will get reduced, the volume will not change. That means what? Whatever the soil volume was initially, the pores, the voids is now filled with water. Now as we are drying, the voids is getting replaced with air and not water. So this is the point where even when drying or reduction in the moisture content, we can say that it will not cause any decrease in the volume of soil mass. So this is called the shrinkage limit. Okay, so this is the liquid limit, beyond which if we add more moisture, the soil will go to a liquid state. This is the plastic limit, beyond which the soil will act as highly deformable. Okay, and this is the shrinkage limit, below which the soil will not show a decrease in its volume even when there is a reduction in the moisture content. Okay, is it clear? Is it clear? Any doubt regarding this?
Yes, sir. Yes, sir.
Okay,
Yes, sir.
fine. So This was the concept of shrinkage limit, plastic limit, liquid limit. Next question was, yes, flow index is measure of particle flow after complete saturation, degree of stiffness after reduction in moisture content, slope of the flow curve in liquid limit test, difference between liquid limit and plastic limit. What is the answer? What is the answer, anyone?
Slope of the flow curves.
Yes, slope of the flow curve in the liquid limit test. So how does the flow curve look like to obtain the liquid limit, and which apparatus do we use to obtain the liquid limit?
Casagrande.
Yes, yes. Okay, this is the Casagrande apparatus. Now this is the flow curve, right? This is the flow curve. So here we have the number of blows. We have the number of blows on the x-axis in the logarithmic scale, isn't it? In the logarithmic scale, and we have moisture content in the normal scale. So this is a semi-log graph. Okay. Now for a particular slope, if I say that this value is initially W1, now it is reducing the moisture content, and this value is W2, and this value is this is N1 and this is N2. Okay, at W1 this is N1, W2 this is N2. So what is the flow index formula? Tell me.
Delta W.
Yes, W1 minus W2 divided by log to the base 10 N2 by N1, right?
Into. Yes, sir.
Yes, N2 by N1. This is the value of the flow index. Okay. So flow index is the slope of the flow curve in the liquid limit test. This is the flow index. Okay, let me check this. Still recorded. Yes, okay. Save it. Next question. Let's see. Yes, a soil has liquid limit of 20% and plastic limit of 14%. As per IS classification, the soil is, options are inorganic silts with high plasticity, organic clays of medium to high plasticity, inorganic clays and silts of low plasticity, or inorganic clays of medium plasticity. You can use this graph now. Okay. You can solve it now and tell me what is the value of plasticity index you are getting over here. Tell me. What is the formula for plasticity index?
Liquid limit minus plastic limit.
Yes. So what is the value of plasticity index you are getting over here?
14.
No, plasticity index. Plasticity index.
Yeah, that's only, sir. 20 minus 14. Okay, 6, sir.
Oh, 20 minus 14. I just heard 14 from your end. I don't know.
Yeah.
Might be wrong. Yes. So it is 6. Yes, 6. 6 is the 6% plasticity index. So now, how do you solve it?
Does it require any calculation? No, I think, sir.
No, no more calculation. Just one calculation. And now, what to do? Say liquid limit of 20%. Liquid limit 20%. So this is the point. Okay, where we should
Yeah,
focus
let's
on.
do.
And then 6% means this range. Then this shaded range. It's from 4 to 7. So it is falling over here. So what is this? CLML means what? First of all, in this graph, this A line, above the A line, we have soils of what? We have clayey soils, right? We can see we have clayey soils, and below that clayey soils, and that is inorganic. And below the A line we have mainly silts and organic soils, right? So this is falling above the A line, okay, falling above the A line. Now below this boundary, liquid limit equal to 35, that is low plasticity, low compressibility, okay. And this one ClMl, that is clays and silt above the A line, so inorganic clays and silt of low plasticity, isn't it? The third one, is it matching now, or there is any doubt? You can tell me.
There is only one low plasticity is there, no, sir? Less than 35.
Yes, less than
Yes,
35 is the only, this is the low plasticity range, this is the intermediate plasticity range, and this is the high plasticity range, irrespective of the A line,
Yes, sir.
irrespective of the A line, okay. Above the A line, we are just discriminating between the inorganic soil and the organic soil,
Okay, that's-
okay. And this is the only region, shaded portion above the A line, where we can see there is a boundary condition of clay and silt. Generally we can see above the A line it is clay soil, below the A line it is silty soil. So above the A line means inorganic clay soil, and below the A line means organic silty soil, okay. This is the only exception, where above the A line we can also see silty soil with clay soil, okay.
Sir, small doubt, sir.
Yes, please.
Somewhere I have seen the questions.
Hmm.
There is one more line above the A line called upper line, U line.
U line, okay.
What is that? As per which codes it is? The U line will come into
I have to check. You said U
Okay.
line, right? U line.
U lines, capital U line, like A line, U line.
Okay, I have to check. I have to
Okay,
check this
done.
because I am also listening to this the first time. But it
Okay.
might be some other classification systems, obviously, because this graph is only with respect to the IS
Indian
Indian,
Indian
standard. Okay,
Yeah.
so that might be something different. I have to check. Okay.
Okay.
Yeah. So the answer to this question is the soil is inorganic clays and silts of low plasticity. Okay. Next question. Let's see what the question is. Which of the following is constant for a given soil? I want Dheeraj to answer this question. If you are still there, please try to answer this question. Which of among these property is constant for a given soil?
Sir, I'm not sure, but I guess for dry unit weight.
No, yeah, I think it's not the correct answer. Anyone else wants to answer this question properly? ARV, do you want to answer this?
Gamma, yes, sir. Yes, is a constant. Dry unit is a variable.
So, which is the answer over here? Second or third?
Second is a correct answer.
Very good. Second is the correct answer. Why? What is bulk unit weight? Bulk unit weight is,
Variable.
yes, bulk unit weight gamma equals to mass by volume, total volume.
Yes, sir.
Soil solids gamma S, mass of dry soil divided by volume of the soil solids. Dry unit weight gamma D, the basic definition I am just talking about, gamma D, mass of dry soil again divided by total volume. Oh, why this is becoming so sensitive? Yeah, total volume. And saturated unit weight gamma sat, okay, equals to saturated mass divided by total volume. Here just replace mass by weight because I have written gamma, so it should be the weight anyway. So see, in option number 1, 3 and 4 I am using total volume. Total volume means in the three-phase system consisting of solid, water and air, which is variable for a given system of soil, but Vs is constant. Hence unit weight of soil solids is constant for a given soil. Okay, and just save it. Yes. So which of the following is constant? Unit weight of solids. Next question. BIS, that is the Bureau of Indian Standard Soil Classification, is based on, what is the answer? Dheeraj, can you tell me the answer of this question? BIS classification is based on?
Sir, both of these.
Both of these. Both of these. Okay. So, anyone else wants to correct this answer, or thinks this is the right answer?
It's correct, sir. Both of these.
Yes, both of these. Very good. Why? Because we all know grain size distribution, it is an important parameter for classification, and also plasticity properties. Very simple. We have just now seen the plasticity chart and the classification of soils as per organic, inorganic, low plasticity, high plasticity, medium plasticity. This is the IS classification system only. That is the Bureau of Indian Standards. So yes, we can say very definitely that BIS soil classification is based on both the grain size distribution and the plasticity properties. So both of the above over here is the correct option. Okay, both of the above is the correct option. Very good. Next question. Yes, this is multiple select questions. So, for a same soil type, the effect of heavier compaction is to: first option, decrease the optimum water content; second option, decrease the maximum dry density; third option, decrease the effective shear stress; and last option, increase the maximum dry density. What is the answer? What are the answers?
Sir, can there be two options?
Yes, obviously, this is a multiple
Two
set
correct
question. Yes, there can be two, there can be three, there can be four. Tell me, what are the correct options?
To decrease the optimum water content
Okay,
and increase the maximum dry density.
okay. So your answer is 1 and 4. Option 1 and option 4. So the other person in this meeting, A or B, do you want to correct this answer, or do you want to agree with this answer?
Agree with this, sir.
Yes, okay, because this is the correct answer. Decrease the optimum water content, yes, and increase the maximum dry density. So heavier compaction, how does it proceed? So we have the compaction curve. On the x-axis, what do we have? On the y-axis, what do we have? What is the parameter on the x-axis in the compaction curve?
Water content,
Yes, and on the y-axis,
gamma D.
yes, dry density or dry unit weight. So with one particular compactive effort or compactive energy, suppose the graph is like this. Okay. Now if we increase the compactive energy, compactive effort, that is with the heavier compaction, the graph will look like this, isn't it? Left side up. So here we have one value of dry density and OMC. What do we have here on increasing the compactive energy? We have a lower value of optimum moisture content and a higher value of maximum dye density. So if we say this is gamma D2 and this is gamma D1, gamma D2 will be more than gamma D1. And if we say this is OMC1 and this is OMC2, so OMC2 will be less than OMC1. OMC2 will be less than OMC1. So optimum moisture content is decreasing and side by side the maximum dye density is increasing. Okay. So option 1 and option 4 both are correct. Just a moment. It's not updating again. Yes. So here option 1 and option 4 both are correct. Okay. I'll just save it. Any doubt till now regarding the questions or anything else? Okay, so I'll continue with the next question. Let's see. Yes, neutral pressure is first option always tensile, second option always compressive, third option compressive below water table and tensile above it, last option compressive above water table and tensile below it. So what is the correct answer? What is the correct answer? Anyone?
C, sir.
Compressive below water table and tensile above it, right?
Yes, sir.
Anyone else has any other opinion about this? Okay, let's not just we'll check how it occurs. This is the ground level, okay, and this is the water table. So below this the neutral pressure is positive, compressive. Above this there is suction force, that is capillary suction. This is negative. So here I'll just do it like this. Yes, here we know total stress equals to effective stress plus pore pressure, isn't it? And what is here? Here total stress equals to effective stress minus pore pressure, right? So in this region above the water table, which is more, effective pressure or total pressure? Above the water table?
Where, sir? Above the water table, effective
Yes.
is more.
Effective is more, and below the water table total is more, right?
Yes.
Yes. So neutral pressure, that is the pore pressure, being tensile above the water table because of capillary suction, the effective pressure over here is more than the total pressure. Okay. So the correct answer is neutral pressure is compressive below water table and tensile above it. Yes, good. Okay. Next question. Seepage pressure is very easy question. What is the correct answer? Seepage pressure is
Pore pressure. 1.
pore pressure. Okay. ARV, do you want to agree with this or do you have some other opinion?
No, sir. It is a pressure exerted by percolating water on the soil.
Yes, yes. Pressure exerted by the percolating water. So pore pressure, static pressure, water is in the void exerting pressure, but when the water is moving, percolating, okay, at that time we call it as seepage pressure. Water seeping through the pores inside the soil. Okay, so though the concept is similar to pore pressure because we are dealing with water in the voids, in the pores of the soil mass, It is not definitely the pore pressure, it is the pressure exerted by the percolating water on the soil. Okay, so seepage pressure is option 3, pressure exerted by percolating water on the soil. Okay, this is what seepage pressure is. I hope it is clear. Next question. Seepage velocity is, what is seepage velocity? Rate of discharge per unit cross section area of the soil, rate of discharge per unit cross section area of the voids, discharge velocity under constant head or discharge velocity under variable head. What is the answer? Anyone? Dheeraj, if you are there, or ARV, yes, you can speak if no one is answering.
Option B, sir.
Yes, very good, very good. Option B is the correct answer. Why? Because, for example, we have a cross section of soil showing the soil mass and water is, percolating to the voids. So these are the solid particles. Then this is the voids, the black portion. Now generally what we do as per Darcy's law, Q equals to KIA, we say discharge, okay, velocity or discharge velocity is equals to Q by A. A is the entire area of cross section, but in generally soil is not flowing through the entire cross section, it is flowing only through the voids. V as seepage velocity. Then we come to seepage velocity. This is Q by the area occupied only by the voids. So naturally Vs is becoming more than V. So seepage velocity is more than the discharge velocity, right? Seepage velocity is more than the discharge velocity, right? Or is it wrong? Any validation or change in this statement that seepage velocity is more than discharge velocity?
Correct, sir.
Yes. Why? Because AB is less than A, obviously. So this is I believe, because as per my opinion, this concept is very important, because
Yes,
in practical considerations we don't actually go by the formula which we use while solving permeability or seepage using Darcy's law. It is not the entire cross section of the soil through which the water is flowing. So in many cases when we follow the general examples, there will be so many cases of overestimation or underestimation of the volume of water. Okay, so we need to know this very carefully. So yes, seepage velocity is the rate of discharge per unit cross section area of the voids in the soil mass and not the entire cross section area. Okay, so this is the correct answer, option 2. Okay. Next question. Contact pressure depends upon the elastic properties of soil only, footing only, both of these, or none of these. What is the answer?
Sir, both of these.
Yes, I believe you are there in that class where I have shown you the problems of the contact pressure. The soil, whether it is cohesive or granular, or the footing, whether it is flexible or rigid, on both these properties, the contact pressure on the footing, it will depend, because the type of soil will have influence on the pressure, whether it is maximum at the center or maximum at the edges, and whether the pressure is uniform or not, that will be influenced by mostly the type of footing, flexible or rigid. So yes, soil and footing both have influence on the contact pressure. Their elastic properties will have influence on the contact pressures. Okay, so both of this is the correct answer. Good. Next question. In partially saturated soil, the initial consolidation is due to. squeezing out of water from the voids, expulsion and compression of air in the voids, expulsion of highly viscous water, or none of these? What is the answer? Anyone? What is the answer?
Sir, option A.
Squeezing out of water in the from the voids. Okay. This is by Dheeraj, right? ARV, do you want to agree or do you want to deny and say
No,
something
sir.
else?
No, sir. No, sir. It
So
is
what-
expulsion of the air.
Yes, yes. So, see, this is the thing, no? This conceptual questions you need to understand, because going forward, numericals you will be able to solve. You know the formula, you just, you know, go by rote learning and just learn the formula and you just solve the problems. But these are the conceptual things. So, soil has a three-phase system, right? Air, water, and solids. Air, water, and solids. So, partially saturated soils. That means it has water in the voids and also air in the voids, isn't it? So, initial consolidation has three phases. Okay, initial consolidation is the first stage of consolidation. In stage 2, we have primary consolidation, isn't it? Primary consolidation. And in stage 3, we have secondary consolidation. I have a question regarding secondary consolidation. So, before the water will move out, obviously the air will come out, right? This is the phase 1, initial consolidation. Whatever the air is trapped in the voids, it will first come out. The volume starts decreasing and then the water starts come out in the second stage. So, in partially saturated soils, initial consolidation means at first in the three-phase system, the air from the voids will be expelled out, leading to compression. Okay, and then in the secondary, in the second stage, that is the primary consolidation stage, the water will squeeze out from the voids. That is the first option is for the primary consolidation, but initially it is the air. Okay, so generally we consider the primary and secondary to be the main phase of consolidation. This is more like, you know, a warm up stage, but still I have mentioned over here initial consolidation, that means the phase 1. So, it is obviously the expulsion of air in the voids. Is it clear? So, in partial
Yes,
saturated
sir.
soil, yes, initial consolidation is due to expulsion and compression of air in the voids. Okay. Next question. Consolidation of soil is due to load which is static short term, dynamic short term, static long term, dynamic long term. What is the answer? Anyone can tell me the answer?
Sir, option C.
Yes, static and long term for consolidation. What is the option for compaction?
Dynamic and short.
Dynamic and short term. Yes, for compaction, dynamic load it can change, and short term loads. Okay, because only the expulsion of air is the thing we are concerned about. So, consolidation of soils is due to load which is option C or option 3, static and long term load. Check. Okay. Static and long term. Yes. Next question. Secondary consolidation is mainly due to the expulsion of highly viscous water, plastic readjustment of solid particles, both of the above, none of this. What is the answer? I believe Dheeraj can say, he was there in the class.
Sir,
Yes, you just said sir and you just turned yourself. Yes.
as I remember, both of the above.
Yes, yes, as you remember, but it is actually both of the above. It is not like you should understand. Okay, why both of the above? Because when when the highly viscous water, okay, that is adsorbed on the solid particles, like this is a solid particle and this is the viscous water absorbed. So, you have to understand that adjacent to this there is another solid particle, right? So when this viscous water is moving out, okay, now this is not the actual pore of the soil, okay, this is, suppose here is a soil particle, here is a pore, okay, the water moves out and then compression, but this is not the actual pore, this is the attached to the surface water. Now if it moves out, then these particles will rearrange themselves in a way that it is plastic in nature, it is permanent in nature, there will be no going back. This readjustment after the expulsion of viscous water will be plastic in nature, okay. So this is mainly what happens during the third and last stage of consolidation, that is the secondary consolidation. The viscous, highly viscous water, they get expelled out, leading to the plastic rearrangement of the solid soil particles, okay. So yes, both of the above is the correct answer. Secondary consolidation is mainly due to the expulsion of highly viscous water along with plastic readjustment of solid particles. Yes, good. Okay, let's see the next question. This is a numerical. Anyone can tell me the formula? The soil mass compared at a moisture content of 12%. So we have moisture content, we have bulk unit weight of 18.73 kilonewton per meter square. Find the dry unit weight. What is the formula for dry unit weight? Anyone?
Gamma bulk by 1 plus moisture content.
Yes. So gamma bulk is 18.73, 1 plus 0.12 is the moisture content. Solve it, you will get
Option B.
approximately, yes, approximately 16.72. Yes. Okay. So dry unit weight equals to bulk unit weight divided by 1 plus moisture content. So concepts and formulas, you have to remember both if you want to solve and understand at the same time. Okay. Next, another numerical. Soil sample has a specific gravity of 2.7 and optimum moisture content of 16%. What is the theoretical maximum dye density in gram per cc that can be achieved for this soil? So how do you obtain the dye density maximum, gamma d max, over here? For this case, what will the degree of saturation? S equals to how much? We will consider 1 or 0 or 0.5.
1, sir.
Yes, S equals to 1. So the formula becomes G rho W divided by 1 plus E. What is E? WG by S. Here we have S equals to 1, W sat and G. Okay, so moisture content W sat is 0.16, G is 2.7 and rho W, as we all know, it is 1 gram per cc. Solve it and tell me the answer. What is the answer?
C, sir.
Yes, 1.885 gram per cc. Good. 1.885 gram per cc is the answer. Okay. Okay, let's see the next question. Yes, the hydraulic head that would produce quick condition in a sand stratum of 2 meter thickness if specific gravity of soil solids G equals to 2.7 and E void ratio is 0.7 is. How do we solve this? What is the procedure? First of all, we have to find out what for the quick condition. Which property need to find out initially for the quick condition, quicksand condition?
IC by I is equal to 1.
IC by I equals to 1. That is the factor of safety, right? But I am asking
Yes.
over here as a hydraulic head that would produce the quick condition. So first of all, let's find out the IC.
Critical height.
Yes, what is the formula?
G minus 1 by 1 plus C.
So what is the answer you are getting? G 2.7 minus 1, 1.7, 1 plus 0.7, 1.7, we are getting 1, right? We are getting 1. Okay. Now this is the hydraulic gradient that would produce the quick condition. And what is the value of the hydraulic gradient? Isn't it hydraulic head divided by the length of the traverse or the thickness of the soil? Isn't it?
Yes.
So the hydraulic head that would produce will be equal to IC into L. Now L is the sand thickness, is equal to 2. So the head causing this quick condition in this scenario would be equal to 1 into 2, that is 2 meter. So the answer is third option 2. Is it clear?
Yes, sir.
So we first find out the critical hydraulic gradient and then we find out using the definition of gradient, that is the head causing the flow divided by the length of traverse and the thickness of the soil strata. So IC equals to H by L. H causing the flow is equals to IC into L, that is gradient into thickness. 1 over here IC equals to 1, L equals to 2. So we are having 2 meter. I'll just write over here. This is the value of L. Okay. Okay, so I believe we have one question. Yes, this is the last question. A soil has a discharge velocity of 6 into 10 to the power minus 7 meter per second and a void ratio of 0.5. The seepage velocity in 10 to the power minus 7 meter per second is. Here you can find out the answer. Any answer from 18 to 18.2 will be accepted. So please solve it and let me know how you are solving it. What is the formula? At first we have to find out which parameter. Initially we need to find out which parameter. Are you there? Am I audible?
V by porosity is equal to discharge velocity.
Yes. So firstly we have to find out the porosity. What is the formula of porosity from void ratio?
E by 1 plus E.
E by 1 plus E. Okay. So here I will be using decimal. If you want to use fraction, it is your choice. So if I use decimal 0.5 by 1.5, I am getting up to 2 decimal places. 0.33 I will mention over here. Okay. Now you can also write it like 1 by 3. Okay. Now what is the formula? Velocity, seepage velocity is equals to discharge velocity divided by porosity. Now this is the discharge velocity V. Okay. So 10 to the power minus 7 I have already mentioned over here, 6 divided by 0.33, and if you write it like 1 by 3 it will be 6 into 3. So according to my answer it is 18.18. Have you done it in a fraction way? Have you solved this and got the answer as 18.18 or 18 just?
18, sir, round figure.
Yes, round figure. So hence I have mentioned that any value from 18.00 to 18.2, because if someone rounds this value to 1 decimal figures, they will get 18.2, isn't it? So this is the range of the correct answer over here that I can say that can be accepted. Okay. So again the concept is, first of all, find out the porosity, that is void ratio divided by 1 plus void ratio. Next, discharge velocity divided by the porosity will give us the seepage velocity, okay, which is the actual velocity which is the water is flowing through the voids in the soil mass. Okay. I hope the concepts are clear. Any doubt regarding this session?
Fine, sir.
Yeah, okay. So I'll say thank you for attending the class. It had been, a very interactive session. I mean, this is the fourth time I'm taking the NPTEL session, but this session, this particular NPTEL session was very interactive. All the sessions with many insights into the concepts of geotechnical engineering, along with, so many things for others to learn. So I wish you all the best, and and just keep on learning, I'll just say. And thank you for attending the classes, it means a lot. Okay.
Sir, is it the last session taken by you in this
Yeah,
particular course?
this is the last summary session. I believe you have missed the yesterday's session, right? Session 12. ARV was there, I think, the only person.
Yes, yes, I missed
Yeah,
actually.
so it is no problem. I believe you will be provided with the links to the YouTube videos, and also the Google Drive link for getting the, solved PPTs. Okay. So even if you have missed it, there is no issue. Yes, ARB, you to say something?
Even from my side,
Yes, sir. Yes.
from audience or listeners side,
Yeah.
I feel very happy, and this session was very interactive,
Okay.
and you are clarifying a lot of doubts politely,
Yeah.
and giving the topics also beyond everything, and it's a mixed questions, calculations, and MCQ, and everything is there. Even whatever we learn in the class is mostly theoretical.
Yeah.
But Sir used to give beyond the undergraduate course also some
Okay.
valid points, consultancy point of view, and everything.
Okay.
But most of the calculation part you are covered very well. So everything I felt comfortable. Thank you for that, sir.
Yeah. Thanks
And
again. Yeah.
and is it possible? I don't know. I should not ask actually. If
Yeah.
in future, if you have any doubts, how to clarify it, because the session is going to close today.
That I cannot say, because
Yes. Yeah.
I don't believe I will be, because this is, I believe, the last time I am
Okay.
attending. I am conducting this kind of sessions, and in future I am not going to be conducting NPTEL as part of my PMRFTA. In
Yes,
any
sir.
other form, if I do, then I'll see. But this is kind of the last, class as this TA duty I'm doing. So that's why I said, and you were the most interactive person.
Yes, sir.
I had to ask others, but you were the most interactive person, which made this session, more fun, more, you know, easy
Yes, sir.
to grasp, understand for everyone. Because one side, if I say go on explaining, it will be boring. So
Yes,
interaction
sir.
is
Yes, sir.
always
Correct.
essential.
Yes,
Anyway,
sir.
thank you all for attending the class. I wish you all the best. Okay.
Thank you, sir. Thank you. All the best for your
Thank
program, sir,
you.
research program also.
Yeah, yeah. Thank you so much. Thank you so much.
Thank you, sir. Thank
Yeah,
you, Dheeraj also.
yeah. Thank you.